Hello, grade 12s. We are tackling 2.6 today, which is where we really introduce the concept of repeated payments in either our investments or as withdrawals. So this is going to be the time in our unit where we're really seeing PMT, PY, and PMT end or beginning really coming into play. Now, we've talked about this before, but just a little really quick recap. PMT is used for anything that is repetitive, whether that be a repeated deposit for an investment or repeated withdrawal or a loan. Now, that direction is the same thing when we talk about PV, is that direction is negative if it is a deposit or positive if it's going to be a withdrawal. We've seen this before, but if there's no payment, that value 0. This is going to be the section of the notes where we don't see it stay at 0 very often. Okay? PY just tells me the number of payments I am making per year. So I'll often see that as monthly or weekly, or every time I get a paycheck, and then the question will tell you how often they get paid. Right? So we can figure that out, but it's usually not stated to you as a number. It's usually stated as some sort of word. And then PMT, end or beginning, every single time we've seen it so far, it's been end. But remember that if I am making an investment, the longer it's in that account, the more interest it'll earn. So if I invest money at the beginning of a month or the end of the month, that's going to make a difference over the long haul of how much money I have. Now, it is assumed that if we are not told when that payment is being made, then it is at the end of whatever payment period. However, if it is beginning, it will say explicitly in the question. It might just say at the beginning of every month. But again, it also might say they do it on Monday of every week, which implies the beginning of every week. Or they're doing it on the first of every month, right? It'll be somehow stated in there if it is in fact at the beginning. Otherwise, everything else stays the same. So we're going to tackle these questions here. And question 1 and question 2A, you could actually probably figure out on your own if you gave this a try. So please pause the video, try it on your own. And then once you've given those a shot, then come back and we'll do it together. Okay, welcome back. So we are taking a look. We are investing $250 per month. This is a repeated payment or repeated deposit. So this is going into PMT, not PV. And it even tells me how frequently I'm doing it. It's doing it monthly. Interest rate, 6.25%, compounded semi-annually over a period of 5 years. I want to know what my money is going to be worth if that interest rate remains unchanged. Now, something I will point out, it says the interest rate remains unchanged. TVM could only handle questions where the interest rate is being stagnant. It is staying the same. If my interest rate, say for example, changed after the first 3 years, so for 3 years it was 6.25%, but after 3 years it went down to 6%, I would have to do a separate TVM for every period of time where that interest was different. Because I cannot input 2 interest rates. I can't average them. That's not how it works. I'd have to do 2 separate TVMs. Here I don't have to because the interest rate remains unchanged, but just something worthwhile pointing out because you might see a question down the road that might use that skill. Okay, so I know I'm using TVM. I know that because I'm looking for my future value and its compound interest. Okay, as I go here, there are certain values that I can automatically plug in and I shouldn't really question. I% and compounded semi-annually, which is 2 times a year. I am looking for my future value. I'm looking for what my money is going to be worth, which means every other value has information in the question that I could find. Now, let's talk about PV and PMT. Remember, PV is when I have a one time investment at the very beginning. I don't have that in this question. It doesn't tell me I started off by investing $3,000 and then I add $250 every month. It doesn't tell me anything of what I'm starting off with, which means, I need to assume I'm starting off with nothing. It doesn't tell me otherwise, so I assume I am starting off with nothing. That $250 is negative because it's leaving my wallet and going into the account, but it goes into PMT because it's happening over and over and over again. If it was $250 once and never, ever, 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 ever again, then fine, it could go in PAV. But because it's happening every month, it's a PMT, it is a payment. It is happening every month, so payments per year is 12. Now, it doesn't tell me when I'm investing that money other than every month. It doesn't say at the beginning, it doesn't say at the end. So it is auto-assumed end unless stated explicitly as beginning. For my number of years, that's my PY, which is 12. My number of payments, is PY, which is 12, times my number of years, which is 5, which gets me 60. Now I can plug that in. When I plug that in, I get 17,518.9890. My final answer has units. It is rounded to 2 decimal places because it is in fact money. So this is how much money my investment will be worth after those 5 years. Okay, so far nothing's really changed. It's just now we're considering these. They are not just default 0 and 1. Cool? Cool. Now, example 2, part A, again, very similar to things we've tackled before. So Zoe invests $1,500 in a savings account for her son, then in the day he was born. Each paycheck, she invests an additional $50. The bank account earns 2% interest compounded monthly. If Zoe gets paid semi-monthly, how much money will be in the account when Zen turns 18? Okay, so lots of different things for part A, but we're still just looking for my future value, right? So my future value in an investment that is compound interest, that earns compound interest, I have to use TVM for. But I also am looking at this and I'm seeing a lot of information that goes into TVM anyways. Hopefully I can acknowledge that that is my starting point. Okay. Now there's a couple of things here that I want to talk about before we do that. There's 2 things automatically, without question, that I usually can always tackle. And that's my interest rate and my compounds per year. It's compounded monthly, so that's 12 times a year. Okay. When I'm looking at this, I know I'm looking for FV, right? I want to know how much money will be in the account when he turns 18, which is great. Now here I'm looking at PV. PV is that one-time payment that's done at the beginning. And I'm told that Zoe's investing $1,500 in the account the day he was born. Okay, so that's negative $1,500 because it's going from her wallet into her account. Okay, the day he was born, doesn't actually tell us anything other than confirming that it is in fact over a span of 18 years, right? Because if she did this when Zenon was 2, well then by the time he turns 18, that length of time is 16 years. But the day he was born, that doesn't tell me anything other than I'm going from year 0 to year 18, which is 18 total years. Okay, I'm looking for PMT, and I see that I'm making a repeated investment of $50 every paycheck. Again, that is negative. And we do that every paycheck. Now, it doesn't say in that exact sentence how often she gets paid, but later in the question, we find out she gets paid semi-monthly. So every half month, so 24 times a year. Because if there's 12 months, then there's 24 half months. Now, it doesn't say when she's making that investment. Okay, she's just saying every paycheck. So we are auto-assuming end here. My N value is my PY times my number of years. And we end up with 432. Lovely. Okay, now we can figure this out. This is only part A, so I'm going to actually make sure I'm leaving room for part B here. But I'll kind of move this up a little bit. No, I have room. Okay. But when I plug that in, I should get to $28,134.17. Okay. Something I will point out is that last question, I didn't round right away, and I, expressed my answer with that $sign after. I am also welcome to do that over here as well. Just jump straight to that final answer with the appropriate units and the appropriate rounding. Dealer's choice. Whatever you do is okay in that situation. Okay, that is part A. Part A is not really new, not really different from the previous question, but part B we haven't really seen before. And that's asking how much interest will Zoe have earned on her investment at the end of 18 years. Now, this is talking about interest in dollars, not the interest rate. Now, when we talk about how much interest she has earned, we cannot, and I repeat, we cannot use this formula. Why? Because we are having compound interest here. This formula is only for simple interest. So even though this formula involves the dollar amount of interest, it is not okay. So how do we do that? Well, that's actually just the top line of the rate of return formula, right? In my rate of return formula, that top line, that numerator, is what the dollar amount of interest is. Which we could think of as current value of portfolio minus previous value of portfolio. Now, when I take a look at this formula, the fact that I'm talking about just the numerator, on my formula sheet it doesn't tell me that numerator represents the dollar amount of interest. But it might be worthwhile noting on my cue card study sheet somewhere that that's what it represents. So if I'm asked a question about interest and I'm talking about a compounding interest rate, then that's something that I know that I can turn to. Now again, this is done or said in a very formal way. But the current value of my portfolio, that's just my future value. That's what I just found out. That is my $28,134.17. My previous value of my portfolio is what I actually invested. Now, what I actually invested is a combination of two things. It's what I started off at the beginning investing and my repeated investments and the number of times I've done that. So this kind of formula here we've talked about before when we were talking about rate of return. Okay, that might be worth noting that helps me calculate the dollar amount of interest. Now I know all those values. That is not new to me. So I'm going to plug them in. $28,134.17 minus $1,500 plus $50 invested, a total of 432 times. When I plug this into my calculator, so super important that I have brackets here. Why? It's because I'm subtracting the total amount I've previously invested. And the total amount is all of this. So if I don't put in brackets, I will get an incorrect answer. I can actually just plug it in as is, though, as long as I involve the brackets. Okay? And that's no problem. I will point out that this part, or I will remind you that this is going to then also be the numerator of my rate of return formula if I was asked to calculate the rate of return. But this just tells me the total dollar invested, how much I actually invested to altogether. So when I do that, I end up with, I'll do the bracket separately just so we can talk about it a little bit. When I plug in the bracket separately, I end up with $23,100. And altogether, my dollar amount of interest is $5,034.17. Okay. Now this question is broken down to you in two parts, right? It's saying figure out my FV first, then calculate my interest. Partially because I'm being a little bit nice, right? I know that you need to find the future value in order to calculate my dollar amount of interest. And so I put it as two questions to help you get there. But I could have very well just asked you part B. I do not have to ask you my future value first. Now, 3 separate follow-up questions that I can ask you that require you to get FV first. So 3 different ways I can structure a question so that part B is slightly different. The first way is exactly what we did. Say calculate the dollar amount of interest. And quite honestly, on my formula sheet or in my study sheet, I would very much want to write this down, right? It comes up quite a bit. It's worthwhile, even though it's something I could memorize, or just this is an understanding piece. My dollar amount of interest is the difference between how much I ended up with minus how much I invested, right? That extra money, where did it come from? It was the interest. But I would say it's worthwhile to include. The next way I could have asked this question is I could have just said, over, the span of 18 years, how much did Zoe invest in the account? And that's just this. I do not like the color of that highlighter with the light blue. Sure, dark yellow. Okay, and that's just this. Now that also actually might be worthwhile to indicate on my formula sheet that the total dollar amount of interest, the total dollar amount invested, not of interest, that was a slip up by me. The total dollar amount invested is just this part here. It is my PV plus PMT times N. Now the third thing I could ask you, of course, is what is her rate of return? And I guess there's a fourth thing. I could ask you, what is the average annual rate of return? Now, every question can be slightly different because I can ask you different follow-up questions, right? But A, understanding the question of what to do, and B, understanding the process of how to get there is the difficult part, okay? So very, very, very strongly recommend that we write those down. We have them easily accessible to us. It's something that when we tackle new questions that we can always refer back to. Okay, moving on. So we are going to compare the following pair of investments over a 2-year period. A bank offers an interest rate of 10%, holy smokes, per annum, which is what P.A stands for, compounded monthly. Determine the future value of each investment. Okay, option 1 and option 2, very easily something that you can tackle on your own. And the question below asks you which of the 2 options is a better choice. Now what I'd like you to do, I'd like you to pause the video. I'd like you to try and figure out option 1 and 2. And then I'd like you to figure out how you can decide which of those 2 options are better. And then use that strategy to tell us the answer. Oops. Okay, so that is your job. Pause, go. Okay, welcome back. So, a couple of things here. 10% compounded monthly. I want to find the future value. This is for both of the questions, option 1 and 2. So 10% compounded monthly, and I'm looking my future value. 10% compounded monthly, I'm looking for future value. Here, option 1, I'm simply told $24,000 is invested once, which means I know it is a PV, right? PV is a one-time investment or withdrawal, whatever. But it is only done once, so that's a PV. Here I have no payments, so my default is 0 for PMT, 1 for payments per year, and end. And my N is 1 times my number of years. The question says it's a 2-year period, so I get 2. When I plug that in, my future value, I end up with $2,928.94. For option 2, I'm investing $200 at the beginning of each month. Okay, so since that $200 is repeated, that goes into my PMT. It's happening every month, so PY is 12, and at the beginning, so I have begin. I don't have a PV. There's nothing told to me about a one-time investment, so that's 0. And my N is 12 times 2, which is 24. This future value, when I plug it in, ends up being $5,333.46. Okay, reminder. When I want to compare of which of these two options is better, the only time I can compare directly if there is only, nothing different except my final answer and one other thing. So like if my compounding periods were different or my interest rate was different, but everything else was identical. But here I don't have that. Here I'm investing a different amount at the beginning, and here I'm investing something repetitively, okay? And I'm actually not even investing the total amount being the same both times. Right here, I know I'm investing a total of $2,400. And here I'm investing $200 24 times, which is actually quite a bit more than $2,400. So what we learned last lesson was the best way to compare things was either rate of return or annual average rate of return. Because both of these investments are over the same period of time, rate of return will just do the job just fine. Annual average rate of return doesn't actually give me better or more information in this case because the number of years is the same. So we are going to calculate the rate of return for both of these options, and we are then going to compare the rate of return to make my decision. So my rate of return is, I could use the formula current value of my portfolio minus previous divided by previous times 100%. Or I could think about this as my total amount of interest divided by my total amount invested. Both give me the same answer. Okay, in option 1 is actually pretty straightforward because when I take a look at my total amount invested, it's pretty straightforward. Sometimes, not always, but sometimes, I like to actually just put a separate line of my total amount invested. Why sometimes? Because sometimes it's just straightforward. Like here, I probably wouldn't have done it. I'm going to do it for this. But the reason I wouldn't have done it because it's just the number 2,400. Right? We invested once. That's how much we invested. So that's our total. Pretty simplistic. Right? We could always think about this as the more formal kind of process we just talked about, where this is PV plus PMT times N. But that's just 2,400 plus 0 times 2, which just ends up being 2,400. Okay, so I could use this formula, but in this question, it's pretty straightforward. Now, my rate of return is equal to my current value of portfolio, so 2928.94, minus my previous amount, which is the total amount invested, over my total amount invested, my previous value, times 100%. And I can plug that in. Now I'm going to plug this in a little bit at a time. Keep in mind, if you plug it in all at once, you need to put brackets around the numerator. But I'm going to plug it in a little bit at a time, just to remind you that that calculated numerator is my dollar amount of interest earned, right? So if I did ask about the dollar amount of interest, that numerator of my rate of return formula is in fact that value. Okay, that's why I wanted to plug it in step by step, but I should get 22.04% if I round to 2 decimals. Okay, the next one. Total amount, total dollars invested. Okay, and I can think of that formula if I want to. It's a little bit more useful. Plus PMT times N. Well, my PV was 0. My PMT was 200. And I'm multiplying by 24. I end up with 4,800. Now, as a reminder, whether it's straightforward or not, this is always what I'm doing to figure out my total amount invested, which is what I'm always doing to figure out the previous value of my portfolio. Those two things are synonymous. They are identical. They represent the same amount of, or same information. So in my rate of return formula, I get my current value minus my previous value divided by my previous value times 100%. Again, I'm going to do it step by step, really just to point out that the difference in that numerator is my interest earned. So if I was asked how much interest earned, my dollar amount, that numerator is exactly that value. But when I plug that in, I get 11.11%. Quick, make a wish. It's 11.11. Okay. Now, again, the question wasn't calculate the rate of return for both. That was the strategy I was using to compare these two investments. And the reason why I'm using rate of return and not average annual rate of return is because it's over the same amount of time for both investments. It was both over 2 years. Now that I have the rate of return for both, I just look for the bigger number. Obviously, the more I get back for my investment, the better it is for me. So option 1 has a higher rate of return, so option 1 is the better choice. Okay. Last question. The last question is actually an old provincial question, and I think it's a pretty good question. There's quite a few steps in here, which I kind of love, but I want us to go through them. I want us to really understand them, and this is something that you can definitely see again down the road. So a lot's going on here. At age 30, Alfred began investing $350 monthly into an investment account at an interest rate of 7% compounded monthly. When he turned 45, the interest rate on his investment decreased to 5%. Okay, compounded monthly still. Alfred plans to continue making monthly investments until he is 58. Okay, lots of information there. But one of the things that I want to point out is we have two interest rates. Remember earlier in this video, I said if interest rates change, I have to do two separate TVMs because there is no possible place for me to input two separate interest rates into my TVM calculation. So I have to split this information into two sections. Now when I'm taking a look at these two sections, when does he get 7% interest? Well, he gets it from age 30 to age 45. So he gets it for the first 15 years of his investment, right? 45 minus 30 is 15. So for 15 years, he gets 7%. When does he get 5%? Well, he gets it from 45 to 58. So 58 minus 45 is 13. He gets it for the last 13 years of his investment. So we here in this question A, we want to know how much money he will have in his account when he retires. We're looking for the future value, but we will have to do two TVMs to get there. The first 15 years, and then another one for the next 13 years. Okay? So, here I go. So this is the first 15 years from 30 to 45. Okay, so in the first 15 years, I know a couple of things straight off the bat. I know my interest rate is 7. I know it's compounded monthly. I know I'm looking for my future value. When I take a look at PV, I don't actually see an initial amount that's in this account at the very beginning. But I do see that $350 is a repeated payment, which means I have a negative $350. It's happening monthly, so PY is 12. And it doesn't say when in the month he's investing that. So I am assuming that my PMT at the bottom is end. My N is 12 times 15, which gives me 180. Now when I plug this in, I'm looking for my future value, aka the value of the account when he's 45, right at the end of the first chunk of time, at the end of those 15 years. And we find out that it's $110,936.80. Now, this is not my final answer. Why? Because I don't care about how much money he has at 45. That's not what the question asks. But I care how much he has when he retires. Now, I couldn't jump straight to the final answer that I want because of that change in interest. So I need to do another TVM for the next 13 years, from age 45 to 58. Right? I get 13 because 58 minus 45 is 13. Now, I'm going to do the same thing. I still have to do a TVM. Okay, and when I do that, my interest rate is now 5%. Yep, 5%. And it's compounded monthly. But this is where this question's a little bit special. I understand at 45, he's not making a one-time lump sum, but there is money in that account when he is 45. How much money's in that account? Well, this is how much is in that account, right? Because that first TVM we calculated is how much money he has at 45. So what we can picture is that what's happening when my interest rate changes is you can picture Alfred being at the bank being like, hey, look, your interest rate is changing. Here's all your money. And Alfred being like, okay, well, I don't want it now. Here's all my money back. And then continually making those monthly investments. Okay? Which means my PV is exactly my FV from my previous TVM. Except I need to remember that I'm inputting it as a negative because that is an investment, not a loan. When we look at the rest of this question, he's still making monthly investments until he retires. So we're still seeing this negative $350 as a payment. We're still seeing it monthly. We're still seeing it at the end. My N is my PY times my number of years, which is 13. Which is 156. My future value at the end of the day when he's age 58, when he's retiring, is $288,905.48. This is my final answer. Okay, a couple of really important things to say here. Not that we haven't said them already, but just a refresher. I can never plug in two separate interest rates into one TVM. Here, Alfred only had his interest rate change once, which means I need to do one TVM for each rate. But even if it changed 3 times, well, I'd still have to do one TVM for every single rate. Every single previous FV gets filtered in to the next PV because he's not starting from scratch. Even though he started from scratch at the beginning, he is not starting from scratch later on. It's just simply I cannot get TVM to do different interest rates, so I need to set it up from the beginning. But PV, there's already money there. Okay? So this question's great for the different interest rates that we see, but that's kind of how we would tackle that. Okay, this question doesn't end. So Alfred, right now, at the end of this question, Alfred is 58 years old. This is how much money he has. He is retired. Remember, he was making monthly payments until he retires. So after 58, he no longer is investing $350 every month. Let's see what he's doing. Alfred withdraws $2,000 per month from his account after he retires. So at age 58, he's retiring. He's now withdrawing $2,000 each month. The interest rate remains at 5%. How many months can he withdraw $2,000 for? Now, when I take a look at this, I'm still kind of pulling information from that previous question, right? Right now, at the beginning of Part B, when he retires, he has $288,905.48. I found that in Part A. That information is needed for Part B. In this question, I have an interest rate, and I am looking at a repeated withdrawal. So I still consider this a payment, but it is a withdrawal instead of a deposit. Okay, when I look at this, I'm still looking at TVM. Because that interest rate is remaining at 5%, and that interest rate prior was 5% compounded monthly, so I'm maintaining all of that status quo. The question does not have to repeat it if it is remaining unchanged. With that being said, the 5 and the 12, same. Now, just like before, my previous FV became my new PV. That is happening here as well, because at age 58, he has invested $288,905.48. $905.48. He is not taking that out. That still exists. He's still hoping to earn interest on it, so it's still staying in the account. Now, I'm told that Alfred is withdrawing $2,000 per month. It's happening repetitively. That's at PMT. This time, it's positive. Why? Because that direction of money flow goes from his account to his wallet. So it is a withdrawal. It goes in the opposite direction of the investment. So it's positive. It's happening every month, which is 12 times a year. It does not say when that is happening, the beginning or the end, so we assume it is the end unless stated otherwise. Now, I am looking for how many months, and I don't have my N right now filled in, and I don't have FV filled in. Based on what the question is asking me, that should give me a hint of which one is unknown. Okay? Future value doesn't actually tell me anything about the amount of time, but my N is calculated by doing my PY times my number of years, which ends up telling me some information about the number of the amount of time, which means I'm looking for N in this question. Now, some of you might be looking at this and being like, okay, but what's FV? Like, where do we do? Like, how do we plug that in? Let's just think about it. This is Alfred's retirement savings plan, okay, which is great. We know Alfred's no longer putting in more money, right, because Alfred's not working anymore. He's not getting any more money from anywhere else. He's just taking money out to live off of. Now, when I take a look at this, what will cause Alfred to stop withdrawing? Either A, Alfred passes away, right? But we have no indication about Alfred's, health, whatever. We're just going to assume Alfred's going to live forever. He's going to just keep on withdrawing money. When else would cause Alfred to stop withdrawing money? Well, when he runs out, okay? What happens to my investment when there is no money left? What is the future value of that investment? Well, when there's no money left, my future value is 0, right? So this FV gets inputted as a 0 because Alfred will keep withdrawing until there are $0 left in that account, okay? So if it does not say that, that is information that we can fill in the blanks for based on logical context of what happens when you withdraw money and when you would be forced to stop. Now when I do this, plug this in, I get N is 221.50. There might be decimals that follow, but that's okay. Why am I saying that's okay? Because when I take a look at my N stands for the total number of payments. Now, Alfred's making payments. Oops, that's not highlighter. Alfred's making payments monthly. So if N, the total number of payments, is 221.5, it's technically in the same amount as the number of months, because if he's making payments monthly, the number of payments is the same as the number of months. It's in the same unit as my PY. Now, you might know this, and you might not, but let's just pretend we didn't know this. And I'm like, okay, I got N is this. Well, I know that N is payments per year times the number of years, which means I could plug in the values I know to get the number of years. And I could divide both sides by 12 to get that value. Ooh, and I actually didn't write that value down. Let me quick whip out a calculator. And that's 18 0.45833, blah, 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 etc. That's my number of years. But if I want to convert years to months, what do? Like, it's set up a unit conversion. But I'll notice that I'm just going to re-multiply it by 12. And when I re-multiply by 12, I get the exact same number I started off with. Right? So this strategy, something that I would always kind of use, I would always have in the back of my mind, because what if the amount of time that I'm interested in is different than the units of what n is measured in? But I might notice when my PY is monthly, my number of payments are going to be the same as the number of months. If PY was daily, my number of payments would be the same as the number of days. If PY was yearly, my number of payments would be the same as the number of years. So I might get there. Now, the question talks about how many months can you withdraw money for, specifically 2,000. Now, the months that I say should be whole units, right? Shouldn't have decimals here. So I am going to round my final answer. But he can't actually do it for 222 months, because after 221 months, I don't quite have $2,000 left, hence the decimal. So I actually have to round down here. So my final answer would be 221 months. Okay, now I realize that this question was a lot to kind of take in, and that's okay. It's not meant to be easy, but it is meant to be understood. So if you have questions about things as things go on, please jot them down and please talk to me about them, and I can help process you through this if there's parts where you're still confused. Speaking of parts, we have part 3, or part C. We have Alfred's sister, Marianne. She retires at age 60. Her portfolio is valued at $200,000, earning 5% compounded monthly. If Marianne wants to make the money last until she's 85 years old, what is the maximum she can withdraw each month? Okay, now we're starting to talk about Marianne. Marianne is different from Alfred, which means I'm not actually pulling any previous information from part A or part B. To answer this question. This is a brand new question, talking about a brand new person. Alfred didn't give any money to Marianne. There's nothing going on other than the fact that they happen to be related. Okay, we want to know how much money she can withdraw each month to have her money last until she's 85. When I take a look at this question, what am I looking for? Well, I want to know that repeated amount she can withdraw, which means I'm looking for PMT in this particular question. I know I'm using TVM because interest is compounded. That's my only strategy I have for dealing with compound interest here. So let's just dive right in. Okay. When I take a look at this, my interest is 5%. It's compounded monthly. 5, 12. I am looking for the maximum she can withdraw. That is a repeated thing. I am looking for PMT. Now, I'm expecting my PMT to be positive because she's withdrawing it. If I plug this in and I get a PMT value spat out and it's a negative, I probably either messed up my sign somewhere or I've plugged something in incorrectly. So just something to be mindful of what to expect about that final answer based on what I know the situation to look like. Now, Marianne right now has $200,000 in that account. So here we are, $200,000. It's negative because it's in that account. It's an investment. My future value, well, we want that money to last until she's 85. When does that money run out? When there's $0 left. Okay. My PY, how often she wants to make that withdrawal. She wants to make that withdrawal each month. So PY is 12. Doesn't say when she's making that withdrawal, end or beginning, so it is assumed end. Now my N is my PY 12 times my number of years. Well, my number of years is the difference between 85 and 60. Because she's 60 now, she wants it to last until she's 85. So that's over a span of 25 years. Which means N is 300. When I plug this in, I get a positive payment of $1,169.18. This means that every single month, Marianne can take out $1,169.18 so that after 25 years, when she turns 85, she will have used up all of her money. Now, something I will point out, the question says what's the max she can withdraw? Because technically, she could withdraw less. She could choose to withdraw $1. The money will still last. That's cool. But we're looking for the maximum. That's why my future value is set to 0. Because if I'm maximizing how much I can withdraw, I'm trying to use it all up. So that is why that word maximum is there. Because if it just says, what could she withdraw each month to make the money last? She could withdraw a penny. She could withdraw a nickel. She could withdraw $5.72. But what's the max she can withdraw? Well, the max she can withdraw would be enough so that at the very end, she is left with $0 left. Okay, that is it. That is all. Please do the practice that follows. Otherwise, have a great rest of your day.